Chapter 3. Motion in a plane. Summary 1. Scalar quantities are quantities with magnitudes only. Examples are distance, speed, mass and temperature. 2. Vector quantities are quantities with magnitude and direction both. Examples are displacement, velocity and acceleration. They obey special rules of vector algebra. 3. A vector A multiplied by a real number lambda is also a vector, whose magnitude is lambda times the magnitude of the vector A and whose direction is the same or opposite depending upon whether lambda is positive or negative. 4. Two vectors A and B may be added graphically using head-to-tail method or parallelogram method. 5. Vector addition is commutative. A plus B equals B plus A. It also obeys the associative law. A plus B plus C equals A plus B plus C. 6. A null or zero vector is a vector with zero magnitude. Since the magnitude is zero, we don't have to specify its direction. It has the properties. The subtraction of vector B from A is defined as the sum of A and B. A, B equals A plus B, 8. A vector A can be resolved into component along two given vectors A and B lying in the same plane. A equals lambda A plus micro B, where lambda and micro are real numbers. 9. A unit vector associated with a vector A has magnitude 1 and is along the vector A. The unit vectors I, j, k are vectors of unit magnitude and point in the direction of the x, y, and z axes, respectively in a right-handed coordinate system. 10. A vector A can be expressed as where A, x, A, y are its components along x and y axes. If vector A makes an angle theta with the x-axis, A11, vectors can be conveniently added using analytical method. If sum of two vectors A and B that lie in xy plane is R, then Ri j equals plus RRX y, where R x equals A, x plus B, x and R y equals A, y plus B, y. 12. The position vector of an object in xy plane is given by and the displacement from position R to position R is given by increment R equals R minus R. A. 13. If an object undergoes a displacement increment R in time increment t, its average velocity is given by the velocity of an object at time t is the limiting value of the average velocity as increment t tends to 0. It can be written in unit vector notation as 14. If the velocity of an object changes from v to v in time increment t, then its average acceleration is given by a versus v. The acceleration at any time t is the limiting value of a as increment tz0. In component form, we have a. 15. If an object is moving in a plane with constant acceleration and its position vector at time t equals 0 is r. Then at any other time t, it will be at a point given by and its velocity is given by v equals o plus at, where v o is the velocity at time t equals 0 in component form. Motion in a plane can be treated as superposition of two separate simultaneous one-dimensional motions along two perpendicular directions. 16. An object that is in flight after being projected is called a projectile. If an object is projected with initial velocity v, o making an angle theta, o with x-axis, and if we assume its initial position to coincide with the origin of the coordinate system, then the position and velocity of the projectile at time t are given by the path of a projectile is parabolic and is given by the maximum height that a projectile attains is the time taken to reach this height is the horizontal distance traveled by a projectile from its initial position to the position it passes y equals 0 during its fall is called the range, r of the projectile. It is 17. When an object follows a circular path at constant speed, the motion of the object is called uniform circular motion. The magnitude of its acceleration is a. C equals v2, r. The direction of a c is always towards the center of the circle. The angular speed omega is the rate of change of angular distance. It is related to velocity v by v equals omega r. The acceleration is a. C equals omega 2r. If t is the time period of revolution of the object in circular motion and nu is its frequency, we have omega equals 2 pi nu, v equals 2 p n r, a. C equals 4 pi 2 nu 2r. Points to ponder 1. The path length traversed by an object between 2 points is, in general, not the same as the magnitude of displacement. The displacement depends only on the end points. The path length, as the name implies, depends on the actual path. The two quantities are equal only if the object does not change its direction during the course of motion. In all other cases, the path length is greater than the magnitude of displacement. 2. In view of point 1 above, the average speed of an object is greater than or equal to the magnitude of the average velocity over a given time interval. The two are equal only if the path length is equal to the magnitude of displacement. 3. The vector equations 3.33a and 3.34a do not involve any choice of axes. Of course, you can always resolve them along any two independent axes. 4. The kinematic equations for uniform acceleration do not apply to the case of uniform circular motion, since in this case the magnitude of acceleration is constant but its direction is changing. 5. An object subjected to two velocities v1 and v2 has a resultant velocity v equals v1 plus v2. Take care to distinguish it from velocity of object 1 relative to velocity of object 2, v12 equals v1 minus v2. Here v1 and v2 are velocities with reference to some common reference frame. 6. The resultant acceleration of an object in circular motion is towards the center only if the speed is constant. 7. The shape of the trajectory of the motion of an object is not determined by the acceleration alone but also depends on the initial conditions of motion, initial position and initial velocity. For example, the trajectory of an object moving under the same acceleration due to gravity can be a straight line or a parabola depending on the initial conditions.